Hello students, in last session our exercise 8.3 completed. Now we discuss one new topic, trigonometric identities. As we know what is identity. Identity is true for all the value of variables. For the identity we know equation. Equation has the left hand side and the right hand side. And equation, first of all, what is identity? And equation is called an identity when it is true for all values of the variable involved. Say example, a square minus b square is equals to a minus b, a plus b is an identity because left hand side and right hand side are equal for all values of a and b. Okay, but x square minus 25 is equals to 0 is an equation because this equation is satisfied only for x is equals to 5. If you have to put x is equals to 5, square of 5, 25 minus 25 and we get 0. The left hand side is equals to right hand side is equal only for the value of x which is 5. But not true for another value of x. Got it? So that it is an equation, but a square minus b square is equals to a minus b. In another bracket a plus b is called identity. As we know there are lots of identities are there. Now we see the trigonometric identity. Trigonometric identity. An equation involving trigonometric ratio of an angle is called a trigonometric identity if it is true for all values of the angles involved. this session we discussed three trigonometric identities. The first identity is sin square theta plus cos square theta is equals to 1, where there is some condition where 0 less than or is equals to theta less than or is equals to 90 degree. Sin square theta plus cos square theta is equals to 1. Now we make sin square as a subject. We get sin square theta is equals to 1 minus cos square theta. Now we make cos square as a subject. Cos square theta is equals to 1 minus sin square theta. So that keep in mind these two forms using the identity sin square minus cos square is equals to 1. Now the second identity is sec square theta minus tan square theta is equals to 1. It is our main identity where the theta is greater than 0 and less than 90. But what about include 90 or include 0? For that we have to see the table. From the table, sec 0, value of sec 0 is 1 and the value of tan 0 is also 0. But at that time tan 90 is not defined and sec 90 is not defined. That's why we can't include 19, exclude 90, but included 0. 0 less than or is equals to theta less than 90 degree. Now for that we have to make one time sec square theta as a subject. Sec square theta is equals to 1 plus tan square theta. And tan square theta, by making tan square theta as a subject, we shift one right hand side to the left hand side and we get sec square theta minus 1. Okay. These two sec square and the tan square are obtained from sec square theta minus tan square theta. Now another third last number identity, which is main identity, cosec square theta minus cot square theta is equals to 1. Now 0 less than theta less than 90. Now what about 0 and 90? They are excluded or included? For that again we need to see the table. From the table, see the value of cosec 0 and cot 0. Cosec 0 is not defined and again cot 0 is not defined. But at the 90, cosec 90 is 1 and cot 90 is 0. So that we have to take here 90 but exclude 0 from the value of theta. Okay. Now we make one time cosec square as a subject and second time cot square as a subject. Cosec square theta is equals to 1 plus cot square theta. And by making cot square as a subject, cot square theta is equals to shift 1 right hand side to the left hand side, cosec square theta minus 1. Okay. Main identity is sin square theta plus cos square theta is equals to 1. Sec square theta minus tan square theta is equals to 1 and cosec square theta minus cot square theta is equals to 1. Okay. From that we have to keep in mind some relations. First number from this, sin square theta is equals to 1 minus cos square theta is written as sin theta is equals to square root of 1 minus cos square theta. Second, cos theta is equals to square root of 1 minus sin square theta. Next is sec theta is equals to square root of 1 plus tan square theta. Tan theta is equals to under root sec square theta minus 1. Sixth is cosec theta is equals to under root 1 plus cot square theta. And the seventh number is cot theta is equals to under root cosec square theta minus 1. Okay. Now the next one is, as we know, tan theta is equals to sin theta upon cos theta is equals to, instead of sin theta is under root 1 minus cos square theta upon under root, instead of cos theta is equals to under root 1 minus sin square theta. Now for cot theta is equals to cos theta upon sin theta. As we know, cos theta is equals to square root 1 minus sin square theta upon under root, instead of sin theta is equals to 1 minus cos square theta. Done. Next thing is that, as we know, the sine is the reciprocal of cosec theta. Sin theta is equals to 1 upon cosec theta. But cosec theta is equals to under root 1 plus cot square theta. And cosec theta is the reciprocal of sin theta. Cosec theta is equals to 1 upon sin theta. As we know, the sin theta is equals to square root of 1 minus cos square theta. Next is secant cosec. Secant cos theta is equals to 1 upon sec theta, where the sec theta is equals to under root 1 plus tan square theta. 1 plus tan square theta. 13. Sec theta is equals to 1 upon cos theta. 1 upon cos theta is equals to square root of 1 minus sin square theta. Now tan and cot. Tan theta is equals to 1 upon cot theta. But value of cot theta in form of cosec, square root of cosec square theta minus 1. Next is cot theta is equals to 1 upon tan theta. 1 upon. Instead of tan theta is square root of sec square theta minus 1. Okay. Now is not to remember, but for just our understanding, is the relation between the all trigonometry ratios are important for some objectives. From the textbook, keep in mind the three identities: sin square plus cos square is equals to 1, sec square plus tan square, sec square minus tan square is equals to 1, and cosec square minus cot square is equals to 1. It also applicable for another value of theta, but theta remains same. Suppose, say example, sin square 30 plus cos square 30 is equals to 1. Cosec square theta minus cot square theta, instead of theta suppose phi, is equals to 1. Sec square alpha minus tan square alpha is equals to 1, but not for sec square theta minus tan square alpha is equals to 1. It is not possible. It is a wrong thing. These identities are applicable only for the thetas remain same. If the thetas are equal, then identities are applicable for all things. Again, one thing keep in mind, sin square a plus cos square a is equals to 1, but not for sin a plus cos a is equals to 1 is wrong thing. Okay, got it? Very well. So that keep in mind these three identities for our next exercise and the examples. Now we discuss examples from the textbook. Let's see the examples from the textbook. Examples are regarding the trigonometric identities, trigonometric ratio, the relations of trigonometric ratios. First of all, see the example number 12. On a page number 191, express the ratios cos A, tan A and sec A in terms of sin A. As we know, the identity sin square, here the angle is A, sin square A plus cos square A is equals to 1. We need to find cos in form of sin, so that we have to make first of all cos square as a subject. Cos square A is equals to 1 minus sin square A. By taking square root, cos A is equals to under root 1 minus sin square A. It is the first value of cos in form of sine. Next thing is tan and the sec. To find the sec is the reciprocal of cos. Sec A is equals to 1 upon cos A. Sec A is equals to 1 upon cos is under root 1 minus sin square A. It is value of sec in form of sine. Now third one is a tan. For the tan, we know tan A is equals to sin A upon cos A. But sin A is equals to sin A. Sin in form of, we need to find this tan in form of sine, so that sin A as it is upon, instead of cos A is square root of 1 minus sin square A. Completed. Tan A in form of sin A. Let's see the next example number 13. From textbook, page number 192. See the question first. Prove that sec A into bracket 1 minus sin A into bracket sec A plus tan A is equals to 1. First of all, we need to write left hand side. LHS is equals to sec A into bracket 1 minus sin A into next bracket sec A plus tan A. Now we convert all the trigonometry ratios in form of sine and cos. Instead of sec A is 1 upon cos A. 1 minus sin A remains as it is. And sec A is equals to 1 upon cos A. And tan A is equals to sin A upon cos A. Done. Now 1 upon cos A remains as it is. 1 minus sin A remains as it is. In next one, we need to take LCM. Cos A. Cos A is the LCM and numerator 1 plus sin A is equals to. Now see in numerator 1 minus sin A. In another bracket 1 plus sin A. Upon cos A into cos A means cos square A is equals to 1 minus sin A and 1 plus sin A is look like as a minus B and A plus B, means square of 1 is 1 minus sin square A upon cos square A. We need to find right hand side as a 1, so that here applying identity 1 minus sin square A is equals to cos square A upon cos square A. because of sin square a plus cos square a is equals to 1. Numerator and denominator both are equal and we get 1, but 1 is our right hand side. Therefore, left hand side is equals to right hand side. Therefore, our left hand side is sec a into bracket 1 minus sin a into bracket sec a plus tan a is equals to 1 is proved. Done. Hence the example number 13 is completed. Now we discuss example number 14. Example number 14 on the same page, page 192. Prove that cot A minus cos A upon cot A plus cos A is equals to cosec A minus 1 upon cosec A plus 1. First of all, write the left hand side. LHS is equals to cot A minus cos A upon cot A plus cos A. We need only cosec A minus 1 upon cosec A plus 1. So that we need to convert this trigonometry ratio in form of sine and cos. Instead of cot is equals to cos A upon sine A minus cos A upon cos A upon sine A minus cos A. Now see in numerator cos are common, in denominator cos are common, is equals to cos A is common into bracket 1 upon sine A minus 1 upon cos A is common into bracket 1 upon sine A minus 1. Now cos cut is equals to 1 upon sine A is cosec A minus 1 upon 1 upon sine A is cosec A plus 1, but it is our right hand side. Therefore, left hand side is equals to right hand side. Therefore, cot A minus cos A upon cot A plus cos A is equals to cosec A minus 1 upon cosec A plus 1 is proved. Hence the example number 14 is completed. Now whenever we meet in next session, we discuss our next example number 15 from the textbook. If you have any query regarding homework, regarding the sessions, please tick mark it very well. Whenever we meet, we can solve it easily.